let's try example 2. Now, example 2, I know it looks like a lot of space, but I had to write really small to put all of this in because there's a lot that goes on with this problem. So either write really small, or you should have some extra space from example 1. So if you want to go into that space, you can to do example 2, because it's going to be a little bit, if you write big, there's a lot to write. Okay, so let's try example 2. So this is more like what a full problem might look like, because this time I gave you the original function, not the second derivative. So if I give you some original function, and I say find all intervals on which the graph is concave up or down, and also find all points of inflection. So the very first step that we would want to do is we need to find the second derivative. And to find the second derivative, we have to find the first derivative. Okay, so let's get practice with this. When I take the first derivative of this function, you see it as a quotient, but just show me with your head nod or head shake, would you use quotient rule on this problem?
No, I'd use power rule.
Correct. Yeah, I would not use quotient rule. Could you use quotient rule? Sure, but I would not. I would use power rule, and really becomes chain rule. So what I'm going to do first is I'm going to rewrite my g function as a power. So that would be 24 times x squared plus 12 to the -1 power. Because of the numerator being a constant, if there was a variable as well in the numerator, I would use quotient rule. Okay, let's take the first derivative. Power rule says I'm going to multiply that 24 by -1, keep the inside the same, subtract 1 on my power, then do not forget chain rule times the derivative of the inside function. I'm going to clean that up before I take that second derivative. So 24 times 2 is 48x. I'm going to bring that to the front. I'm going to leave it as a power since I'm just going to take the derivative again. Pretty straightforward, not too bad. Now, to take the second derivative, what has this now become? It's not just the power or chain rule. It's now also a product. Yeah, thank you. So it's a product of the -48x times that power. Okay, so we got product rule, we got chain rule, we got power rule, we got a lot going on here. So let's just take it step by step. All right, product rule says take the derivative of the first function. That's just -48 times keep the second function the same, plus keep the second function the same. So that's -48x. So I'm just going to write -48x instead of the plus, times the derivative of that second function. That's where we have to do that power rule and chain rule again. So that's times -2 x squared plus 12, subtract 1 again to the -3rd power, times 2x again. There's a lot going on there. If you need to like do brackets, like sometimes that might help to do like brackets, depending on how comfortable you feel with brackets or no brackets. I'm going to pause right there. Let me know if you have any questions. Now, if I had asked you to just simply find the second derivative, you could stop right there. However, I'm going to need to be working with this second derivative, right? Because if I want to find, in theory, if I want to find intervals of concave up, concave down, I really need to find when this second derivative is equal to 0 or is undefined. The way it sits right now, that's really messy. So I need to clean this up a little bit. At first glance, so I'm going to kind of show you guys, it shouldn't be a new algebraic concept, but it's something that we don't do very often. So I'm going to show you something that I would recommend you doing here. Obviously, you could make these into fractions, right? The negative exponent, you could put those in the denominator. But look at something closely with me here. You see how in our first term, we have an x squared plus 12 factor. And over here, we have an x squared plus 12 factor. You can factor an x squared plus 12 out. Now, when you factor something out, don't write this down, but let's say you have x cubed plus x squared, and you were trying to factor out the GCF. What's the GCF there? That's x squared, right? And you would get x plus 1, correct? What are you actually factoring out? You're factoring out the smaller of the two exponents, yes? Okay. When we're dealing with negative exponents, which one is smaller? -2 or -3? Show of hands. -2 or -3? -3 is smaller. So this is a technique that actually, it looks complicated at first, but it's going to actually help us out a lot. And I wanted to show this to you. So what we're going to do is we're going to factor out a GCF. You see, I've got 48 in both. And I've got this x squared plus 12 factor in both. So I'm going to factor that out. If you want to go ahead and factor out the -48, you can. So I'm going to factor out a -48. I'm also going to factor out an x squared plus 12 term. But I'm going to factor out the smaller of the two exponents, and that's the -3. So think of that as my GCF coming out of this whole thing. So now I'm going to put a big old bracket. My first term was this guy right here. What goes in that spot after I factor out my GCF?
X squared plus 12.
X squared plus 12 to the first power. Yes? Everybody see that? Any questions on that? X squared plus 12 to the first power. I'll even put a 1. You don't have to put the 1, but I just wanted y'all to see that. That's that first term. Everybody good with that? In the next term, the whole x squared plus 12 term went away because we factored out all of it. Now let's see, we also factored out the 48 and the negative. So let's see what's next, what's left. We have this x times -2 times 2x. So it's actually going to be minus 4x squared. Are y'all okay with that? So what's complicated here? The algebra for sure. Calculus was not that bad.
Wait, why is it? Okay, yeah, never mind.
Okay, there's a lot going on in this problem. Okay. Now let's clean all this up a little bit. So I've got a -48 that's going to remain in the numerator. I'm going to go ahead and throw the x squared plus 12 cubed in the denominator. And then what's that factor that was in the brackets going to simplify to? You'll see how it's going to be, what, 12 x squared minus 4x squared gives you minus 3x squared. I'm going to pause there. Questions on how I got that? Okay, so that's my second derivative that's been somewhat simplified. I mean, you could manipulate it a little bit more, but you have to get it in that format. You want to get, if you're setting something equal to 0 or solving with it, you want to get it into one single fraction. So
yeah,
we've done
one
that.
thing.
Yes,
In
Connor.
the numerator of your final answer, where did that 3x come from?
Yeah, so you see here in this bracket, we've got x squared plus 12 minus 4x squared. So x squared minus 4x squared.
Okay, I see.
Okay.
Thank you.
All right. So we took the derivative. That was a lot of work, but now let's go back to what we were trying to do. We're trying to find when this function's concave up or concave down. That's looking at when is the second derivative positive or negative. So we've got to do that number line analysis. And remember, what goes on the number line analysis is when your second derivative is equal to 0 or is undefined. When you have a fraction, you're equal to 0 when the numerator is equal to 0. So that's when 12 minus 3x squared is equal to 0, right? You also have, it's really a critical point for f double prime. You can change sign when the denominator is equal to 0, but is that denominator ever equal to 0? No, you have a squared term plus a number. So that denominator is always positive. But if that denominator could ever equal 0, those numbers also need to go on your number line. So the only numbers that go on my number line on this problem is when the numerator is equal to 0, or when 3x squared equals 12, or when x equals plus or minus 2. So we'll make our number line for g double prime include plus or minus 2. Now, to test the values, you're testing g double prime. So you're looking at this statement right here. Since the denominator is always positive, that will not affect the sign. So in the numerator, if you're not quite sure how to do the number line analysis, just plug in a value, plug in 0. If you plug in 0, do you get a positive or a negative in that numerator?
Negative.
Negative. So now you know 0 is negative. And then you have the two different factors, so they're going to change sign at both -2 and 2. I'm going to pause there. Any questions? This is okay? All right, let's wrap it up to kind of show the final answer. So the question asks, when is the function concave up or concave down? So if this was a free response, you've got to always justify your answer. So here's how you would do it. You would say g is, always say g is, or f, whatever function it is, concave up on, anybody want to volunteer what you would say for the intervals? And there's always going to be open bracket.
I'll go.
Okay, you go.
-infinity to -2 open bracket and union 2 comma infinity.
Perfect. And then you just want to make a statement because g double prime is greater than 0. You can say, you can repeat those intervals just like we've done before, or on these intervals is fine. Good?
You always use open brackets because like -2 and
Always.
2 are the inflection point.
Correct.
So
Yeah.
not concave.
Yeah. So with
Yeah.
increasing and decreasing, Alex, you would put the hard brackets there if this was g prime. But with concavity, it will always, 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 always be open. Okay. So now, second, we would say g is concave down on the intervals from -2 to 2. Likewise, because g double prime is less than 0 on this interval. Questions on that? It then said find all points of inflection. So if it says find points of inflection, you can't just say they happen at -2 and 2. You have to actually find the points. So obviously we have points of inflection at -2 and 2 because the concavity changes sign. But to find those points of inflection, we need to evaluate g at plus or minus 2. If you go back and look at g, back to the very, very, very beginning, you see how you're just squaring your x. So do you see how positive and -2 are going to be the same? Right? So you have two different points of inflection, but they're going to have the same y value. So g at both positive and -2 will be 24 over x squared is 4 plus 12, or 3/2. Actually, shouldn't say points of inflection. There, points of inflection would be the actual coordinates. 2 3/2 and -2 3/2.
Should we just do points of inflection plus or minus 2 comma 3/2?
I would take it. I don't know about AP. I don't know. I mean, they should, but I'm not 100%. And if I'm not 100%, then I would say split it up. So for me and like on your homework and my test, that's fine. But AP test, if you're ever not sure, show more. Be more precise.